Last example in this section, one last look at general vector information is, let's start with this picture here. We can see we have this vector v, beginning initial point 0, 0, the origin, ending point AB, and it's going in this direction. And we know we could express this vector v as AI plus BJ using these coordinates from the terminal point. This magnitude of the vector is the length of the vector there. And now some new information we haven't talked about yet in terms of vectors is this angle theta here. And we can see that theta is the angle measured from the positive x-axis. So here's the positive x-axis. So when we talked earlier in the course about angles in standard position, remember we said we're always going to start with that positive x-axis and move in a counterclockwise direction. Well, this is what we're doing here. And this angle theta is in the direction, we refer to it as the direction angle measured from the positive x-axis. So there's our theta. We can use this information, specifically theta and the magnitude, to express a vector in this form, where the vector is going to be the magnitude of the vector times the cosine of this angle theta, and that's going to give us the information, or A, if you will, in front of the I. And then for the B, or the information in front of the J component, we're going to take the magnitude of the vector and multiply it by the sine of theta. So let's see how this would work in this example here. We're told that the jet stream is blowing at 60 miles per hour in the direction of 45 degrees northeast. So we're in the world of bearings. And what we want to do is take this information and express the velocity as a vector in terms of I and J. So as you know by now, I always think that a picture can be quite helpful. So let's do that. Here we have our north, and then we have our east. Obviously, this would be south and west, but for our purposes, it's this northeast that we're going to be looking at. And the wind is blowing in the direction of 45 degrees northeast. So remember, with bearings, we're always coming, it's not starting from here, it's always from this north-south axis. So we're at 45 degrees. So we are heading in that direction. There is our vector. And this angle here, we're told that this is 45 degrees. There's our bearing, 45 degrees northeast. We want to come up with the equation for this vector, and we want to use this format here. So looking at this, we can see that we're going to need the magnitude, and we're going to need this theta here. Looking at the picture that I've drawn here, theta is this angle in here. Remember, theta is from the positive x-axis. So theta, here's our bearing angle, and here's the theta that we're going to use. So you could probably see that it's going to be 45 degrees, but in case that isn't clear to you, theta was going to be 90 degrees minus 45 degrees, which is 45 degrees. So our theta here, this is 45 degrees. So we have the pieces of information that we need. Now let's put them together. And I lost my blue marker. Sorry, but I'm in the mood for the blue. So to come up with this, we're going to have our vector v is equal to magnitude. Right now, I'm just going to use the magnitude, cosine of our 45 degrees, and this is all in front of I, and now, again, the magnitude, and now, whoops, I forgot the S there. Now, we're going to put this in front of the sine of 45 degrees. And I don't think I mentioned this before, so I'm going to mention it now. To help you remember this, remember cosine is associated with x because we had defined cosine once upon a time as x over r. So one way to help remember that cosine x and the I is the horizontal or x component. Sine we defined as y over r, having to do with y, and so sine is going to be the trig function that's associated with the j or the vertical component. So far we have this, and now let's consider what the magnitude would be. In this case, we don't have an ending point here. We don't have an AB that we could use to stick in front of the I and the J, which is why we're using this formula here. So we can't use AB to help us figure out the magnitude the way we have been doing in previous examples. But going back to this example, it says the jet stream is blowing at 60 miles per hour. So that 60 represents the force. That represents the magnitude. So it's going to be 60 for the magnitude. And now cosine 45 degrees I plus 60 sine 45 degrees J. So here is our equation where we have the theta information, the angle information put in, and the magnitude. Now what we have to do is evaluate this because we know the cosine and sine of 45 degrees. And if these weren't 30, 60, or 45 degrees, we would use the calculator to evaluate them so we could come up with some number, some A in front of the I and some B in front of the J. So here the cosine of 45 degrees is square root 2 over 2 J, and then sine of 45 degrees is also square root 2 over 2 J. So we're here, and last but not least, we can clean this up. 60 divided by 2 would be 30. So we would have 30 square root 2j. And again here, 30 square root 2j. Whoops, this is I. So 30 square root 2i, 30 square root 2j. And this would be our vector v representing this jet stream. And so now we can see A would be 30 times the square root 2, and then our B would be 30 square root 2 also. So in this instance, A and B are the same. We're not asked to find the magnitude, but if we were, well, we're given the magnitude. So if we were to use our magnitude formula with this information, we would get our 60 miles an hour.